Deep in the North Sea, 28 miles, 45 kilometers off the Belgian coast, the impossible is happening. Engineers are building solid ground in the middle of heaving waves and violent storms. This is Princess Elisabeth Island. It is the world's first artificial energy island, a 6-hectare fortress of sand and concrete, the size of 12 soccer fields, rising from the water to serve as a giant electrical socket for the entire European continent. When this project was conceived, the ambition was limitless. The goal? To turn the North Sea into a 300-gigawatt power plant by 2050. A massive number. But on the ground, or rather in the water, reality is far more brutal. You aren't just building an island, you are fighting nature in its own home. The biggest enemy isn't the 40-foot waves above the surface, it's what lies beneath. The seabed here is constantly shifting, a chaotic mix of currents and loose sand. So how do you anchor millions of tons of concrete on a foundation that moves like boiling water? The answer begins at a shipyard in Vlissingen, Netherlands. Here they are casting the island's outer walls. They call them caissons, but think of them as colossal Lego bricks. Each one is hollow, 190 feet long, and weighs 22,000 tons. How do you move something that heavy 28 miles out to sea? Simple physics. Because they are hollow, these concrete giants float like ships. Tugs drag them to the precise location, and then valves are opened. Water floods in and the caisson sinks, settling on the seafloor to form the island's perimeter. But placing the walls is the easy part. The center of the island is filled with 3 million cubic meters of sand, and here lies the danger. If a storm hits, wet, loose sand can undergo liquefaction. It turns into a fluid, swallowing everything above it like quicksand. To stop this, engineers use a process called Vibroflotation. They drive giant metal needles into the submerged sand and vibrate them at specific frequencies. This forces the sand grains to lock together, squeezing out the water. In hours, loose seabed sand is transformed into a block as hard as rock. Once the ground is solid, the real purpose of the island begins. It will house a port, a helipad, and its heart, high-voltage direct current, HVDC. These massive machines take the erratic power generated by wind turbines and stabilize it for long-distance transport. And it's all designed to be autonomous. Robots will patrol the island, scaling turbines and checking cables for corrosion. A smart, unmanned industrial city standing defiant against the ocean. By April 2025, the first caissons were down. The engineers had beaten the physics. But just when victory seemed certain, a new monster appeared. The engineers defeated the sea, but they didn't account for an enemy concrete can't stop: the global economy. Overnight, this €2 billion dream turned into a financial nightmare. When the project was announced in 2021, the price tag was manageable. By 2025, estimates exploded to nearly €8 billion. The cost didn't just rise, it quadrupled. Was it corruption? No, it was a war for resources. Suddenly, the US, China, and Europe all decided to build offshore wind farms at the same time. The supply chain broke. There are only a handful of factories on Earth capable of building these massive electrical converters. It became a seller's market. The price of steel, cement, and specialized ships skyrocketed. In early 2025, the Belgian grid operator had to slam on the brakes. Contracts were delayed. Phase 2 of the island, including a critical link to the UK, was scrapped. Yet out in the water, construction continues. The sand is still being pumped. Why? Because stopping now means losing everything. So, why go through this trouble? Why not just run cables directly to the shore? One word: interconnection. Wind energy is fickle. The wind might be blowing in Belgium, but still in Denmark. If nations are isolated, the lights go out. But if they are connected, the grid becomes resilient. Princess Elisabeth Island is designed as a traffic circle for electricity. Through massive underwater cables like Nautilus and Triton, nations can trade power instantly. Surplus in Belgium flows to the UK. Calm winds in Belgium? They import from Denmark. This transforms Europe's grid from isolated islands into a unified web. In a post-2022 world, Europe can no longer rely on gas pipelines from the east. The North Sea must become the continent's power plant. So, I have to ask, is this engineering marvel a glimpse into our future? Or is it a gamble we simply can't afford? I want to read your thoughts in the comments below. If you enjoyed this deep dive into the mega projects shaping our world, make sure to hit that like button and subscribe. I'll see you in the next one.